Carbo Solutions International company profile and global reach. Our mission: to provide total value package of high-quality, sustainable, specialized adsorbent products and services that optimizes economic and performance values to our customers. The CSI business milestones. Between 2000 and 2002, CSI was established, launching its operations by serving major global beverage brands like Coca-Cola and PepsiCo. In 2003-2004, CSI ventured into sugar refining and sold its HPA to phosphatation refinery in Grupo Trios, Guarani, and in Cauca. 2006-2007, CSI expanded its reach by selling HPA products to carbonatation refineries in Dubai and Jeddah. Between 2009 and 2012, CSI was granted several international patents, specifically in the US, Nigeria, and Saudi Arabia. 2013 to 2015, innovated FRSW2 technology for phosphatation refinery and successfully implemented in over 30 sugar refineries across Pakistan. Between 2017 and 2019, CSI provided support for HPA EPC projects across sugar refineries in Thailand, Canada, and the United Kingdom. 2020 to 2023, successfully converted IER refineries into HPA sugar refineries in the Philippines and Yemen. In same year, CSI successfully sold its HPA products in edible oil industries. 2024 to 2025, CSI reached a strategic milestone by installing HPA beet co-refining in Morocco. And to this present, CSI continues to lead the industry by advancing the transition of NEIER and GAC refineries to eco-friendly HPA technology. CSI Global Presence. Our operational network spans over 52 countries, providing dedicated support to a diverse portfolio of over 88 international clients. CSI patented HPA technology in a carbonatation sugar refinery. CSI patented HPA technology in a phosphatation sugar refinery. Established and ongoing global projects of Carbo Solutions International. CSI Global Reach customers. For more information about our products and services, email us at info@carbo-solutions.com.
Carbo Solutions International is an innovation company with a tradition of research and development. CSI focus on innovation, which is the key in gaining a leading position in the sugar-related industries. CSI delivers innovations that address customer and market needs. Consists of team with practical experience in sugarcane, sugar beet, liquid sugar, alcohol, and energy businesses. One of our clients is Lantic Inc., a fully Canadian-owned company whose goal is to offer the best quality sugar and sweeteners to satisfy their customers. Lantic technical team expressed their interest to evaluate CSI's technology, high-performance decolorants, HPD, and high-performance adsorbents, HPA. The main objective is to replace the current bone char decoloration process and implement HPD-HPA technology. High-performance decolorants, HPD, and high-performance adsorbents, HPA, are two-stage patented technology of CSI for purification process in modern sugar refinery. The advantages of using these technologies are lower capital investment, environment-friendly, less footprint, lower cost of infrastructure, more sugar output per day, high energy savings, improved filtration. CSI suggested to Lantic Inc. a modified refinery purification system comprising the following stages: screening for large impurities at sugar melter, updated flotation clarification, HPD color removal at flotation, color removal using HPA, alternative for bone char, double-stage pressure filtration with diatomaceous earth. CSI conducted complete and detailed engineering plan that includes associated drawings and diagrams. CSI also provided Lantic Inc. the needed tools and equipment for the project. A testimonial from Lantic Operations Manager Gary Mustved states that retrofitting of the decolorization process to replace the failing bone char system with CSI single-pass HPA system yielded results comparable to the past results from bone char with regards to color removal, turbidity levels, ash removal, and sugar quality. The CSI system was chosen over other systems simply because of the quick completion timeline and the simplicity and flexibility for adjustment of the system. Mr. Mustved has high praises for the after-sales support and inspections to ensure continuous quality of production. Why do we need fertilizer? Plants rely on a spectrum of nutrients encompassing macro, intermediate, and micro elements. These nutrients are essential for constructing cell frameworks and facilitating a myriad of physiological and biochemical mechanisms within plants. While certain plant categories exhibit the ability to independently synthesize nitrogen, a substantial majority necessitate external nutrient sources. In terrestrial environments, the inherent nutrient ratios stemming from natural cycles often fall short of fulfilling the intricate demands of plant growth. To address this, the application of microbial organic fertilizer emerges as a pivotal strategy. This method serves to augment nutritional content, enhance soil fluidity, and fortify overall plant well-being. Agricultural byproducts, livestock waste, along with materials like feathers, bones, blood, ash, mineral ores, and even earthworms, are recognized as valuable reservoirs of organic fertilizers. These resources play a crucial role in enhancing soil structure and bolstering its inherent properties. Impact of organic fertilizers on soil. Organic fertilizer is a type of fertilizer derived from natural materials that are rich in essential nutrients necessary for plant growth. These materials can include plant and animal wastes, compost, and other organic matter. A living soil holds a wealth of organic matter consists of earthworms. Earthworms adds important nutrient to the soil. Residue. Acts like a garden mulch, it helps soil retain moisture. Microorganism. They help form the glue that keeps soil intact. Cover crops. Cover crops deliver natural fertilizer to the soil, prevent erosion, and increase biodiversity. Impact of chemical fertilizer on soil. While chemical fertilizers have contributed to increased agricultural productivity and food production, their excessive or improper use can lead to a range of negative effects on the environment, human health, and soil quality. A dead soil has this characteristics: bare soil. Water cannot reach the crop's roof to grow effectively. Instead, the chalky dirt becomes runoff that flows right off the field. Erosion. They more likely to occur from unhealthy and unprotected soil. Increased chemicals. These chemicals can cause serious health and environmental problem if they contaminate water. Pests, such as insects and weeds, are more likely to invade fields when the soil ecosystem is too weak to defend itself. An effective organic fertilizer factory model requires an approximate area of 10,000 square meters, thoughtfully divided into distinct zones, including factory area, warehouse, office, environment, composting yard, raw materials yard, and green planting area. This model will have a capacity to produce 34,000 tons per year. Here are several essential raw materials necessary for manufacturing fertilizers: pressed mud, boiler ash, certification mud, sawdust, chicken manure, and peat. The composting process is a natural biological decomposition process that transforms organic waste materials into a nutrient-rich, stable product known as compost. Composting is widely used for recycling organic waste into a valuable soil amendment. A production line is a systematic arrangement of equipment, machinery, and processes designed to efficiently transform raw materials and components into finished organic fertilizers. Each step on the production line plays a specific role in the overall process, ensuring the quality, consistency, and quantity of the final product. The fertilizer's journey from factory to farm involves a series of crucial steps. It all begins with the production of fertilizers in factories, where they are meticulously crafted and stored. These fertilizers then make their way from the factories to the farms. Once on the farms, they are applied to plants and soil, delivering the essential nutrients necessary for robust plant growth. As plants, such as sugarcane, flourish with the support of these nutrients, they are eventually harvested and transported to milling plants. At these milling facilities, the harvested crops undergo processing to create valuable products. Additionally, the milling process generates byproducts and raw materials. These raw materials, in turn, find their way back to the factories, where they are used to manufacture more fertilizers, thus closing the cycle.